Word embeddings is one of the most important topic. Usually what happens is all the machine learning algorithms, all the machine learning, be it machine learning, be it deep learning, be it ANN, or be it any other algorithm, let's say regression or logistic regression or decision trees or random forest or boosting, any of the machine learning or deep learning algorithms, they work only on numerical data, only on numbers. If you have text data, none of the machine learning algorithms can be applied on it. If you have text data, none of the deep learning algorithms can be applied on it. If you have text data, neither, not even regression or logiciation decision tree, none of these algorithms can be applied on the text data. So we have to follow a certain different process. Let us see what exactly the process that we have to follow. First of all, what is text mining? What is text data analysis? What is text mining? Text mining is nothing but making sense out of the text data that we have. Data mining on the text input. You have the text data. Based on that, you're doing all your analysis. That is text mining or the text data. It is also known as natural language processing. Text data is not same as categorical data. For example, if you have a data set, in that data set, you have a variable called region. You have another variable called, let's say, job type. Let's take one variable, region. It takes values east, west, north, south. Now these are text values in this particular column. But is this the text data that I'm talking about? This is non-numerical data, categorical variable. Is this the text data that I'm talking about here right now?
No.
No. This
No,
is
no, sir.
categorical field. Even though this is categorical data, we still treat it as numerical data only. Let's say if you have a numerical table, in that table, one of the column is this. How do you handle this? From one categorical variable, you will create
Four.
four categorical or four binary variables. Each one of them take value 0 or 1. So how do you fill this? Whenever region is
One.
east, 100 0 1 0 0. So basically what we do is, even though it is non-numerical data, we still treat it as a number only. So this process of converting categorical variable, one categorical variable into multiple binary variables, what is this process known as? What is this known as? Can you recollect?
One.
This is
One hot encoding.
either one hot encoding, or it is also known as dummy variable creation, very famously known as one hot encoding. So if you have non-numerical data, which is categorical, we still treat it as numbers only. We don't really need to think about advanced text mining techniques or anything. We still treat that as numerical data only. But the text that I'm talking about, can you give me some examples of text data sources? I'm not talking about categorical data, text data sources. Analyzing what type of data is called text data.
Google reviews.
Reviews. Now, is review as text data? Yes. You have several reviews, thousands and thousands of reviews. You want to find out whether it's a positive review, whether it's a negative review. You want to extract certain piece of information from the reviews. Yes, that is text data analysis. That is natural language. This language has
Twe-
emotions in it. What else?
Tweets with
Tweets,
certain, yeah.
certain information in the tweets. And then what else? What are the other sources? Can you think of some other sources?
I've just done it on healthcare data.
Healthcare data, some of
Diagnosis.
the
Yeah, all the details.
diagnosis details or the narration.
And we pulled out what
Mm.
claims belong to
Mm.
physio, what belongs to dental.
Exactly. And then the news articles. So basically by text data, I mean to say some of the customer emails, some of the customer feedback and reviews, some of the blog articles, tweets and Facebook posts, news articles, social media comments, customer verbatim in the survey. At the end, you have some verbatim. Some of the scanned documents which are converted to text. That's what I'm talking about, text data. These are the text data sources. There is language, there's emotion inside this. It's not just the simple one word. There is a lot of language or the emotion inside this. But you cannot directly go ahead and do the analysis like numerical data. Numerical data is very well structured. Numerical data has rows and columns. For every record, you have detailed information. Let's say this is customer one. Customer one, age is this much. Customer one, income is this much. Customer one, number of loans are these. Customer one, monthly expenses are this. Each column captures a specific information. If I say income, every place, every row will have income value. Every record has almost all the column variables. Easy to perform mathematical and statistical computation. The most important one is easy to perform. You can perform mathematical and computational statistical computations on this numerical data because mathematics are set on the number system. But what is text data? Text data is completely unstructured. Most of the text data is in one column or two columns. Let us suppose if I'm talking about reviews, so I have review 1, review 2, review 3. Let's say if I'm talking about around 15,000 reviews, so these are all the 15,000 reviews. The whole data is in one column. The column name is, let's say, review. That's it. Each record might have different length. Maybe first review is 2 lines, next review is 8 lines, next review is 1 line, the next review is 5 lines. It is very difficult to arrange it as a data set. Text data is not well structured. You cannot expect everybody to follow the same vocabulary. This person has started the review with the word what. This person has started the review with the word the. This person has started the review with the word else. So depending on whatever is their emotion, everybody will be writing their own text. You cannot expect them to follow the same size. You cannot expect them, like, most importantly, let's say in numerical system, if you have +3, if you have -3, there's some distance between them. +3 is the opposite of -3. The distance between them is 6. Numerical system is very well structured, very well defined. That's why mathematical computations are easy on it. But direct computations on the text data, it is not easy. Computers don't understand language. For sure, they don't understand language. Sometimes it becomes very difficult for even humans to understand sarcasm, isn't it? If somebody tells sarcastically, we sometimes feel that maybe they really meant it. How can you expect computers to understand the language? Very difficult, very difficult. So directly on the text data, can you apply machine learning models? Sorry, you can't. Can you apply deep learning models? Sorry, you can't. Can you apply any simple model like regression or logistic regression? Sorry, you cannot apply any of the algorithms that we have discussed on the text data. None of them. You can't even find out something called mean, which is a very simple descriptive measure. Even that you cannot find out on the text data. It doesn't make any sense. So numerical computations on the text data are not possible. That is why text mining or text data analysis, or NLP stands for natural language processing. When you are processing the language or the text data, this NLP has 2 stages. Step 1 is to convert the text data into numerical data. So what we do is we take the text data, we first convert it into numerical data. Once you have the numerical equivalent of the text data, then you can build the machine learning models, because on the numerical system, your machine learning models are well defined. They will definitely work. So you have the text documents data. Directly, you cannot apply machine learning models. Directly, you cannot do mathematical computations. So the initial step is to convert the text data into numbers. Once you convert them into numbers, then applying these machine learning algorithms, doing mathematical computations would be very easy. There are 2 techniques for converting the text into numbers. Converting the text into numbers is almost like giving a structure to unstructured data. These text documents are unstructured and you are converting them into numerical data. That is means you are giving a structure. So giving a structure to unstructured text data, there are 2 methods. One is bag of words technique or one-hot encoding. It is almost equivalent to one-hot encoding. Slightly different, but almost it looks like one-hot encoding, bag of words technique, age-old method. The other one is word-to-vec, or it is also known as word embeddings. Word-to-vec or word embeddings. The term embeddings you will hear very frequently in the space of natural language processing, in the space of generative AI, in the context of large language models. The term embeddings will be used just like a term, like it's a kind of stop word, like everywhere you hear embeddings, embeddings, embeddings. We need to have absolute clarity on what exactly is an embedding. So this whole discussion that we are going to have today is about word embeddings and the importance of it. This is one of the biggest part in the whole ecosystem of large language models. Let us see what is it about. First, we will talk about the first technique. How do you convert text into numbers? By using bag of words technique. This bag of words technique is also known as, like, when you are converting text into numerical structures, the numerical equivalent of the text data is known as DTM. Stands for document term matrix. Document term matrix is the numerical equivalent of the text data. So you have document 1, loved this place. You have document 2, at this place crust is not good. You have document 3, loved it, good thin crust pizza. Like usually in the terminology of natural language processing, a document means one entity, one observation, or one record. A document doesn't necessarily mean one big document like the Word document or Notepad document. No. A document is not a literal meaning of the document. Document means one entity, one record. Usually if you have a data set, in that data set you have one row. Similar to that, here the whole collection of data is known as corpus. You have corpus, In that corpus, I have one document. Let's say if I'm talking about 15,000 reviews, one review is one document. If I'm talking about 15,000 tweets, one tweet is one document. So I have 3 documents, 3 reviews are here. So how do I convert these 3 documents into numbers? This is the way. In the document term matrix, the documents are the rows. Document 1, document 2, document 3. 3 rows are there. The terms are the columns, or the terms are the unique words. What are the unique words? Love, this, place, at, crust, etc., etc. So you have the rows, which are documents. You have the columns, which are the unique words. And what are the numbers here? What are the numbers? What is the number indicating?
Present or not in particular.
This
Availability of the word in the document.
This particular word, how many times it is appearing in that document? Availability of that word in that particular document. At did not appear in that. So blank here means 0, 0, 0, 0. These are all zeros. Apparently this is appearing twice in there. So, and not is appearing twice in here. Good is appearing twice in here. So this is the document term matrix. It almost looks very similar to our one hot encoding. This particular word is part of this particular document or not. This particular word is part of this particular document or not. So let us see a very simple example of document term matrix. Intentionally, I have taken a very simple corpus just for the explanation sake, but later on we will do a real case study. The corpus is king is a strong man, queen is a wise woman, boy is a young man. I have few documents with me. This is a document, this is a document, this is a document. I have few documents with me. That means few rows. Now what I'm doing, I'm trying to convert this into a document term matrix so that I can do some analysis on it later on. So for that, I'm using something called count vectorizer, which will simply create a document term matrix. What this count vectorizer is going to do is it'll try to take every word and find out in which of the documents they are there and how many times it is present. So apparently boy is in the 3rd document. Boy is a young man. So it is in the 3rd document. Girl is in the 4th document. Girl is a young woman. King is in the 1st document. King is in the 1st document. So this is the document term matrix. For example, if I'm doing sentiment analysis on movie review data. So I'll have the review, I'll have the sentiment, and then I'll build a model on this. Next time when you give the review, using this model, I can predict what is the sentiment, whether it is positive or whether it is negative. So directly, if you give the review, machine learning model will say, sorry, I cannot build the model because this is text data. There's no way I can build the model if you are giving me the text data. So what do? I'll take this text data and then I'll convert it into document term matrix format. So can I convert this into document term matrix format? How does it appear? So this is the document term matrix format. The portion that you see here, this is the document term matrix version of this one. Now each of the term becomes almost one variable here. Now if you imagine all of these as variables, now this becomes your X-train data. And then this is a target variable. You have the Y-train, which is zeros and ones, zeros and ones, zeros and ones. Then you can build the model. That is known as bag of words technique. Shall we do a quick exercise and see how exactly bag of word technique looks like? This bag of words is also known as one hot encoding because almost everywhere ones and zeros are there. So let's do one quick exercise. So I'm pasting the code file link in the chat window. I'm also going to supply all this material along with the code file. Have you got the code file link, all of you, in the chat window? So get to the top of this. So we'll import the required packages. Here is a very simple sample data. As I told you, the first exercise that we're going to do is not really a big one, just to get an idea, just to visualize how does it look like. We will use this example. Later on, we will do a real case study. Packages are getting imported. So this is a corpus. Corpus is collection of documents. A document is one particular entry. And then when I created the document term matrix, it looks like this. Now, what is the use of the document term matrix? Imagine you have reviews data. If the data frame looks like this, I have few reviews. I have the sentiment for them. Then how do I create the document term matrix? Finally, the document term matrix for that data would look like this. So you have the document term matrix, and finally you have the target variable. You can use all these 24 columns as the features, and you can use the target variable as the y value or the target variable, and then try to build a model on this. This is method one of the early methods that was used to convert the text data into numbers. Do you see any problem with this, or this is absolutely fine? Execute this once you have the document term matrix for the sentiment data. Give me a confirmation, then we will discuss about what is this document term matrix. Do you have the document term matrix, all of you? This one, the second one that I'm talking about. 10 rows and 24 columns.
Yes, sir.
Now, can I take any amount of data? Can I convert it into this document term matrix and simply do, let's say, if I want to do classification, if I want to find the polarity, whether a particular sentiment is positive or negative, is it possible for me? Is this a good approach? What do you think? What is your opinion? Converting text into documents like this, creating a document term matrix. Is this absolutely fine if we do like this?
It seems to be very lengthy because number of words can go even larger also.
Yeah, that is problem number one. The vocabulary size can be too much. Here, I'm taking only 10 reviews, but in reality, we have 15,000, 20,000 reviews, and the vocabulary of words goes into a huge number, and there will be too many zeros in this document term matrix, isn't it? You cannot expect particular word. Let's say amazing is one word. Can you expect it to be part of every review? Let's say 15,000 reviews are there. Out of 15,000 reviews, how many reviews would actually contain this word amazing? Very few or very high number. One word appearing in every review is very difficult, isn't it? Let's say there's a word called asleep. Do you think asleep will appear in every review or very few reviews?
Maybe every, but the spelling might be different the
Yeah.
way.
So like out of 15,000 reviews, hardly 10 or 15 people would have written it. Or maybe out of 15,000 reviews, maybe 5 or 10 people would have written disappointed. The others would have written something else. So what's happening is this is just a collection or bag of words. And one more thing, in our review, there is an order. Let's say not good. Not good means it's opposite of good. But here there is no order. In bag of words technique, not will be marked as one, good will be marked as one. Not has come twice, good has come twice. So it's just a collection of words. Every review is considered as a collection of words. The meaning behind it is not given any importance. You have written the word, you have framed a sentence. That sentence is broken into words. So it's just a bag of words. It's not a sequence of words. Now, a bag of words or just a collection of words doesn't really capture the true meaning of what you're trying to talk about. Okay. So bag of words has one issue, the vocabulary size. If it gets too much, then we cannot really create it. It is not meaningful, and there are too many zeros. This is like having too many zeros is known as sparsity. This matrix is too much sparse. Sparse means there are a lot of zeros in it. Looks like there is data, but the data portion is very, very less. Usually in the bag of words technique, the document term matrix usually have more than 95% sparsity. More than 95% of the values will be always zeros. The remaining values will be very, very less. That is another problem. Why bag of words technique fails? There is one more big issue. Here, we cannot really keep the meaningful relations intact. For example, if you have young man, king, woman, etc., etc., you converted a young, like this bag of words is almost like one hot encoding. You converted young into this vector. It looks like this. And then you converted man into this vector. Is somebody trying to write, annotate? You converted man into this vector. You converted king into this vector. And then you converted woman into this vector. But the problem here is there's no meaningful relationship which is intact. There's no meaningful relationship which is intact. What does that mean? If you take any of the two vectors, if you take any of these two values, like these are the one hot encoding style, this is the one hot encoding style of woman, this is the one hot encoding style of young. So young and prince are not related to each other. That is fine. king and woman are not related to each other. There is no relationship intact, but there are some relations that we have to keep intact. Maybe young and princess or prince and princess are kind of similar words. So after converting the words into numbers, the one-hot encoding doesn't preserve any relationship between the words. Every word is unique. Every word is orthogonal to every other word. Let's say if this is king vector, then this is man vector, then this is woman vector. So king is dissimilar to woman. King is very much dissimilar to man also. So that doesn't make any sense. So all these numerical representation are orthogonal to each other. That means if you try to find some kind of, you try to use some kind of similarity measure and trying to find how similar these two values are, these two words are, you will find the similarity between them is zero. Everything is orthogonal to everything else. That is why one-hot encoding doesn't work when you are converting the real text, the real natural language into numbers. There, one-hot encoding doesn't work. So where does it work? If you have categorical variable, converting that categorical variable into numerical values, each one of them are binary. Here, it works, no problem. East, west, north, south, those are 4 different directions. There's no relationship between them. So this is east indicator, west indicator, north indicator, south indicator. That is fine. But where it doesn't work, in our example, king, prince, man are very similar to each other. Similarly, queen, princess, woman are very much connected. But when we convert it into one-hot encoding, the similarity between king and prince is 0. The similarity between king and man is 0. The similarity between queen and princess is 0. There is no similarity. So one-hot encoding, they fail to capture the relational structure of the corpus. One-hot encoding, in that one-hot encoding, every word is unique. It has no connection to any other word. And another issue is one-hot encoding vector data is very sparse. Very sparse means there are too many zeros. And most importantly, one of the most important point is you cannot preserve the context. What context you are talking about, that context is not preserved by one-hot encoding. When you say king, there is a context that we should attach to king. When I say king, am I talking about king in chess game? Here, is it the context of chess game, king and queen? When I say king, am I talking about king of spades or am I talking about king of hearts? Is it a playing cards game? When I'm talking about king, am I saying rocking? No. King, from the point of view of king, queen, princess, royalty point of view, we are talking about it. That context is totally lost in one-hot encoding. That is why we need a new representation. A new representation that can preserve the word relations. 2 words that are connected, 2 words that are in the same context, they should have the same type of numerical representation that has lesser sparsity, lesser dimensions, and most importantly, it has to preserve the context. Context is the key word that we need to understand. Somehow context need to be preserved. First of all, how do you get the context in any scenario? Let us suppose on our WhatsApp group, I have sent you 2 messages. Both of the messages have 40 words. This is 40 words. This also has 40 words. Let us suppose this is just a joke forward that I have forwarded, and this is some material. So I have written some information or some material or something related to an article on regression. Now, how do you get the context that this is a joke? And how do you get the context that this is some ML material? How do you get that in general? Context, how do you get that? You read certain words, isn't it? You read some of the words initially. As soon as you read few words, you will get the context that, yes, this is a joke that I'm just forwarding. You read a couple of words, and then you realize that, yeah, this is some ML material. So what do? Ignore this ML material, read the joke, or ignore the joke, read this ML material, depending on whatever is our interest. So you get the context based on the words or the surrounding words. So how do you get the context? By looking at the surrounding words. Surrounding words is nothing but the context. Context is a kind of abstract term. It is at a latent level. Nobody tells us this is a context, or in the text, we will not get an information that this is a context. This is latent, this is hidden. Context is hidden in the words. So if you look at the surrounding words, then you will get the context. So how do you get the context? Let us suppose if I say king. King is in several contexts. You have the king in chess game. Let's say you have king, queen, etc., in chess game or somewhere else, or in some one of the game. You have king in playing cards. So you have king in some other context. Here we are talking about king, queen, royalty, etc. So what am I talking about? What king is that? When I say king, what is the context? You will get to know the context of the king by looking at the surrounding words. So what king I'm talking about? King is in the context of strong. I'm talking about a strong king. King is in which context? Is it playing cards king that I'm talking about. Who is this king? King is also in the context of man. So if king is the word, the context is strong and man. Now, how do you get the context of strong? You look few words before strong. You look for few words after strong. Maybe I look for 5 words before strong. I look for 5 words after strong. So when I say strong, am I talking about strong coffee? When I say strong, am I talking about strong willpower? When I say strong, am I talking about a strong tree trunk? Is that what I'm talking about? When I say strong, which context strong is in? Tell me. Which context? Strong is in the context of?
Strength.
Strong is in the context of, you have to look at the surrounding words. That is the context. Strong is in the context of king. Strong is in the context of man. Let's say you can go like here, there is only one word. If you have 5 words, you will write all those 5 words. Strong is in these 5 words context. Strong is in these 5 words context. Overall 10 words. Again, which context man is in? Am I talking about Batman here? Is that the context that I'm talking about? Am I talking about Iron Man? What is the context of man here?
Strong.
Man is in the context of what? Look for few surrounding words. Look
King.
for, let's say my context window is 5. If the context window is 5, I will go for 5 words prior to that. I'll go for 5 words after that. If my context window is 5, I will get 10 words in my context. Why? I look for 5 words prior to that, 5 words later on that. So man is in which context? Man is in the context of, when I say man, I'm talking about whom?
King.
The king.
King. The man is king. I'm not talking about Batman. I'm not talking about Iron Man. Man is in which context?
Strong.
When I'm saying man, when I say man, I mean to say a strong man. So every word will appear as a word and every word will appear in the context of other words as well. So you will get an idea on the context based on the surrounding words. Then what we need to do, we need to marry the word to the context. Somehow we need to bind them. When I'm converting these words into numbers, I have to make sure that I'm binding them to the context. If I bind them to the context, then it will make more sense. The similarity or the relationships will be preserved. So how do you do that? That is the whole process of word to vec. Words are converted into vectors. In word to vec, there are 2 major steps. We create the training samples. We create the training data by considering word and word in the context. And then we use some machine learning model to train them. Let us see how word to vec works. It has 2 steps. Step 1 is create the training samples. King, strong, man. So how do you create that? King, so this is a word and this is the input is the word, output is word in context. King is in the context of strong man. Strong is in the context of king and man. Man is in the context of king and strong. These are shorter sentences. Originally, if this is the word, if the you can define the context window. If I define my context window as 5, then I'll go 5 words prior to this, 5 words following this as the context. If I take another sentence, queen is a wise woman. Queen is in the context of wise and woman. Wise is in the context of queen and woman. Woman is in the context of queen and wise. So that is step 1. Step 1 is creating a data set where input is word, output is word in the context. Context is nothing but surrounding words. Then step 2 comes into the picture. Step 2 is build a neural network model by taking this as input, by taking this as output. And it has to be a shallow neural network model. What's a shallow neural network model? What's a shallow neural network model?
It is only one hidden layer.
If a neural network model has only one hidden layer, that is known as shallow neural network. So we have to build a shallow neural network by taking this as X, by taking this as Y. Build a shallow neural network by taking this as X, this as Y. That means you have hidden layer with many number of hidden nodes. For our sake of explanation, I'm taking 3 hidden nodes. You can have 6 hidden nodes, you can have 10, you can have 20, any number of hidden nodes. So I'm building a shallow neural network with 3 hidden nodes. Then what I'll do, I'll build the model here. This is X, this is Y. I'll try to train this model. These are the words which is input. These are the context that is output. So king, when king is input, the output is strong and man only. When strong is input, the output was king and man. When strong is input, the output was never queen. When strong is input, the output was never woman. When queen is input, the output was always wise. The output was always woman. When queen is input, it was never strong. When queen is input, it was never man. When wise is input, it was never a man. When wise is input, it was never strong. So input is connected to output only in particular places. So when you build the model on this, automatically these weights are adjusted accordingly. When this is input, only few of them are output. Those weights are adjusted accordingly. Then the final vector form of the word is once you build this model, once all these, what is model building? Once you find all these weights, that is model building. Then later, once the model is built, you supply king as input. You take the intermediate output only. You take H1, H2, H3, these three values as output. That is the vector form. You're not really interested in what is the output, final output. You're not interested in the prediction. You're interested in the intermediate output of king. Once I supply king as input, I don't want to predict what is the output. I want to know what is the intermediate output, H1, H2, H3 output. That is what I want to extract as the vector. So this will be one number, this is another number, this is another number. So that is a vector of 3 dimensions. King has been mentioned. So finally, when you have king, you will have a vector H1, H2, H3. When you say strong, you will have a vector H1, H2, H3. When you say man, so finally the output of word to vec looks like this. King is this vector, man is this vector. How is this vector generated? The intermediate output of H1, H2, H3 in this case. Now, what is the beauty of this particular representation? King and man, if you try to find the similarity between them, either correlation or cosine similarity, they will be having higher similarity. King and woman, if you try to find the cosine similarity or if you try to find correlation or any form of similarity, they will be very less similar. They will be very highly dissimilar. So the numerical representation of king is this one. This is known as vector. This is the word and this is a vector. And what is the beauty of this vector? This vector keeps the contextual information inside it. This vector is very useful. That's the reason why word to vec works much better than one hot encoding, because when you are converting words into vector, you did not convert them randomly. You have made sure that you married input to output. You have combined input, which is word, output, which is context. King and man were connected to this, whereas queen was never connected to this. Similarly, king and man was never connected to wise, whereas queen and woman were connected to wise. So definitely the numerical representation, the vector representation of queen, wise, woman, which are connected, their numbers will be similar, because at the end of the day, the weights will be adjusted according to our neural network that we have trained here. That's the reason why this numerical representation, the vector representation of these words will be very much in line with whatever is the context that we are talking about internally. The words which are in the similar context will get the similar representation. That is how you preserve the contextual or semantic meaning that is called. In fact, if you try to draw these diagrams, since there are 3 dimensions, we can experiment, we can draw it. So if you try to draw this diagram, imagine this is a cube, 3 dimensions, like say this is dimension 1, this is dimension 2. Let me call this as x-axis. Let's say this is a y-axis, this is z-axis. You can imagine this cube which is looking towards you or which is away from you. You can see that there are certain type of clusters that are formed. If you take these axes, probably this is a set of words these are all the words that are kind of near to each other, and these are the kind of words that may be near to each other, or these are the words that are maybe near to each other. Or maybe if you look at it from different perspective, maybe these are looking somewhat similar to each other, these are the ones that are nearby each other. So why these words are like this? What is the meaning of this? It means that the representation of the man, representation of king, representation of prince, if I try to take their values and if I try to put them on a cube, it look like this. Or if you imagine this as actual cube in your hand, a sponge, and if you imagine each word as a small pin, paper pin, and if you try to embed it, so the words that are similar to each other will be embedded closer depending on their values. The words that are in different context, they will be embedded far away. So the distance between king and queen will be far away, whereas distance between king and man will be closer comparatively. The distance between king and woman will be far away, but the distance between queen and woman will be nearby. King and wise will be far away. Wise will be closer to queen, woman, princess, Reddy, etc. These values. The reason why we use the word embedding, it comes from here. If you imagine this whole thing as a cube, on that cube, when you're embedding the words, embedding means just pinning them there, like you just put a pin wherever that word values are there. Then it looks like this whole, the pins that you see, the pins or the embeddings are similar. The similar words will get nearby embeddings or nearby values. So there will be higher similarity between the words that are in the same context. So overall, roughly, if we see, we can see the overall a cluster of 3 or 4 clusters or 3 clusters we can get out of this small example that we have. This word to vec is so powerful that it can even almost equivalent to our human logic. Let's say if I ask you a logical question. So the logical question that I have is, let's say if I take king vector and if I subtract manly properties out of the king, from king you remove manly properties. After removing manly properties, you add women properties. After that, you add wise properties. Take king, subtract man out of him, add woman, add wise. Now logically, if you create a new vector out of it, where that vector should come according to your human logic, is it red or blue or green?
In red, sir. Near to queen.
Near to queen. Somewhere this whole thing logically sounds like queen, isn't it? It should be part of this particular circle. Now if we do the math, I have the king vector with me. I can subtract man out of that. I can add woman, I can add wise. A new vector will come. And if I try to draw this new vector, where exactly it appears here. So the regular human logic that we see, that is also embedded here. So word to vec is the only reason why today large language models exist. Word embeddings is the only reason why NLP is quite accurate these days, because we capture contextual semantic meaning. It was impossible in bag of words. So bag of words technique was there long back. People used to use that. But ever since word to vec came into the picture, the accuracy is too much, too high. It is like almost like a human being, the way that we think, the way that we understand the words and the relationship between them, word to vec captures exactly that. That is the theory behind word to vec. We will do a couple of case studies, not just one. And then an assignment on this will give us complete confidence on word to vec concept. But conceptually, theoretically, are there any quick questions, anybody, on this?
Venkat sir, this first back towards approach, the data set was where it was X is kind of all corpus, and within that there was a sentiment already defined.
Right.
But in this problem, it is only a corpus.
Right.
So when the earlier example, can we use word to vec?
Yes. So basically, in the earlier example, word to vec is used on text data. This is text data. Is this text data? This is not. This is numbers only, isn't it? This is numerical data. Anyway, it is converted. Positive, negative, neutral means 1, 0, -1. So this is already numbers. So I'll keep these numbers as it is. And this particular one I'll convert into word to vec. Okay. These will be converted to vectors.
Okay.
That finally, let's say I'm converting each of the word into 8-dimensional vectors. Then it will be it'll be x1, x2, and so on. X8 features will be there. Target variable y will be there, which can be used for predicting the sentiment.
Okay.
Yeah. So basically, for us, the text data is the actual review data. For us, the text data is the news article data, or for us, the text data is the email data, where I want to find out which category that email belongs to. I want to find out which type of news article that I'm talking about. So for us, the text data is this inside input data.
Sir, I have one more question. So is there any business cases where we should go for one-hot encoding but not word to vec?
So when you have categorical data, non-numerical, but categorical, it's like when we say NLP, if it is natural language data, go for word to vec. Okay. If it is not language data, there is something called semi-structured data. You have log files. A log file in the system is not really language, isn't it? Yes, it looks like language. Some server failure at this time, a warning at this time, critical error at this time. But the vocabulary is quite limited. Do you agree with that? This is not really a natural language where you and I are conversing each other. This is a very limited vocabulary. Hardly 100 or 200 words will be there. Maybe in that, a word to vec doesn't really require. I can still do a bag of words. That is really a bag of words, isn't it? It is not really English grammar is embedded in that. So in those cases where you feel that the vocabulary size is quite less, very limited, it is a kind of semi-structured. It's not completely structured like a numerical table. It is not completely unstructured like a review. When it is semi-structured, then you may have to take a call. Is it like a limited vocabulary? Do you think word to vec is the right one, or do you think the document term matrix is the right one? We have to take a call on the spot there. Okay.
I have an example for him.
Yes, go ahead,
Let's
but
share.
make it quick. Yeah.
Yes, sir.
Yes.
So we just were doing something where industry sector was given. The person working in different industries. There were just 25 industries. So I used actually I used Venkat sir's thing only. I've seen one hot encoding to convert all industry 25 sectors into zeros and ones.
So basically, when there is limitation or limited possibility, then still we can use document term matrix. I think you got the point, right? Like semi-structured data, that is when like neither complete categorical data nor complete text data. In between also you can try. Okay. Make sense?
Sir, one more question.
Yeah, carry on.
Sir, this converting words into vector. So
Hmm.
how does machine process it, sir? Means in backend, like machine doesn't take the characters or words in form of.
So while building this artificial neural network model, we give this as one-hot encoded values.
Okay.
And we also do the one-hot encoding here. But anyway, we don't really care about actual one-hot encoding here. Finally, we supply that one-hot encoding, we take the vector form of it. So to convert this non-numeric text into numbers, the machine converts them into one-hot encoding, the input and output, and then builds the model, and then finally supplies the values to us.
Okay, sir. Sir, every document will have individual shallow neural network, or it will have all together, sir.
So we take the whole corpus, because let us suppose in document 1 you have king. In document 2 also you have king. You don't want to have a different vector here for king. You don't want to have a different vector here king. At the overall vocabulary level, we want to capture all the word relations. So we will take the whole corpus. These are all the words. Like basically you have 2 steps. In step 1, you convert the words into like input output format, right? In that step 1, so this is doc 1, okay? This is doc 2. Make sense?
Yes, sir.
And then doc 3. Like that, your input and output is containing all the documents that you have. This is the final data that you have. Yeah.
Oh, okay, sir.